In November 2022, Thrust SSC team members Richard Noble, Andy Green and Ron Ayres attended the launch of a very special watch brand with clear record-breaking connections. Brooklands racetrack in Surrey is synonymous with brave deeds allied to innovative design and engineering. The Napier Railton, driven by John Cobb and designed by Reed Railton, set the fastest ever lap at Brooklands before they continued their partnership with land and water speed record projects. Brooklands Watch Company follow the same principles of innovation and engineering excellence, and so we're delighted that they have chosen to partner with us to set a new water speed record. Our next project update will cover the development of C3.2B, a 200 mph fully autonomous quarter-scale test boat, which we're currently building with composite specialists PRF. Meanwhile, work continues to refine the craft's control systems, and we'll shortly have exciting news about a truly innovative solution to ensure that the full-size boat meets our design goals of stability and control at 450 mph. Support from Brooklands Watch Company is crucial in enabling us to prepare our chosen test location and run the test boat at full speed, producing real-world data to compare with our aerodynamic and hydrodynamic CFD calculations. Once we have the full picture, we'll know we've achieved our design goals. Look out for more from Brooklands Watch Company when C3.2B is ready to run, but in the meantime, here is Richard Noble talking about record breaking for this exciting new brand, shortly after the launch of the limited edition Brooklands 444 Racing Chronograph.
Well, of course, a world land speed record is about speed. And speed, of course, depends on time, and you've got to have an arrangement where the car is timed over a measured, in our case we use a measured mile generally, or you can use a measured kilometre, and the whole arrangement has to be audited by the FIA, so everybody knows that it's a real record and it hasn't been sort of fraudulently tampered with or whatever. So there you are, you're out on the desert and you're running the car, and the only thing that really matters is the timekeeper's timing, and that's what that takes precedence over everything, and they're timing to 3 decimal places, so it's got to be good and it's got to be reliable. Yeah, on two planes really, measured on 2 planes I guess. One is that you've got to get a project like this together in a certain amount of time, because if it takes too long then people will give up. And so you've got a hell of a pressure to keep going, keep the money coming, keeping the project all headed together, focused and everything else. So there's a lot of that. And then of course when you're out on the desert, then of course it's all about the timekeepers and the time that you achieve. Well, I can't tell you because Andy is the only one who's done that. The only one in the world who's done that. But yes, the extraordinary thing about it is that, and from my point of view, I was standing at the midpoint of the course, and we did 5 supersonic runs. And when you see the car come down, the track is a truly terrifying experience. The car is going very, very fast. It's going faster than any airplane you've ever seen, because it's nearly touching 800 miles an hour. On the desert, we would have something like about 200 media there, and they'd be very, very quiet. And the car would come past with an enormous double bang, 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 like that. That's the supersonic shockwaves. And so powerful that it rocks all the trucks on their axles. And in the little village of Gerlach, which is 15 miles away, it was knocking the covers off the sprinklers in the school classroom. So this is real motor racing. And you could hear the supersonic boom, I'm told, 40 miles away. So it's an extraordinary experience. Well, you're part of a team. The whole thing is a team operation. So my job was predominantly to make the money and also to drive the car. And so what you're doing is every day you're going out and you're going to drive the car a little bit faster. So each time you're moving up the speed range, and everybody's building confidence as you get a little bit faster and a little bit faster, until eventually you get to a point where you can actually drive the car absolutely flat out. But the point about it is the car is always driven flat out. You're never sort of feathering on the accelerator. You're always with your foot flat to the floor, and you're controlling the speed by the running distance. I think there's a different sort of courage involved in all this, really, because it's never a situation where you're just going to get into an unproven car and you're just going to put your foot flat on the floor and you're going to hope that you and the car are going to survive at the other end. Because you're working up to it bit by bit, it's just another day and you're just going a few miles an hour faster. And so you hope that you get better and better at it, and more accurate, because of course everything's being watched by the team and you really have to get it right for them. So that doesn't require so much courage. What does require courage is making the decision at the start of the project that you're actually going to do it and you're actually going to see it through. And once you've made that decision, then that's behind you and now you're just moving forwards. The other bit of courage is about the rest of the team. And it requires an extraordinary level of courage for people to work on a project like this. I mean, initially it starts off as being really interesting and great fun and something really different. But when the car starts to run, then it all changes dramatically. And people then get very worried about that piece of the car. Is it going to work? Is it going to break? Is it going to let us all down? Is it going to result in an accident? So there's a tremendous courage and a tremendous stress right the way through the project and right the way through the team. Very much a team thing. Yeah, my dad was in the army, and we're talking about 1952, and we were living in the Scottish town of Inverness. And one weekend he did what everybody used to do in those days, was get in the Hillman Minx and go for a country drive. And we went round the north side of Loch Ness, and we came to Drumnadrochit, and we came to Temple Pier, and there's a huge crowd of people. And there was a sort of wall around the edge of the road there, and there was a huge crowd of people standing there looking over the wall. And so we had to stop and have a look, and I saw the Crusader, and it was the most amazing thing you ever saw. It was so futuristic, silver and sort of goldfish red. It was a beautiful thing. And I never actually saw it run, unfortunately, but I saw it and I just got totally hooked. And from then on, I was building jet engines in cardboard and, reading books on rocket motors and so on. And then I discovered there was a land speed record, and that's much more interesting, because it was much more faster. So that's kind of where it started. And once you get hooked, you can't really let go. Well, it was a very extraordinary era, really, because, of course, this was immediately post-war. And everything was very gloomy. Basically, there wasn't much money around. It was a gloomy sort of time. But what was actually happening in the aerospace industry was that they were pushing on. They didn't really believe that the war had finished. They expected there was going to be a next generation war, certainly, and this was, of course, the start of the Cold War. So they just kept going. And we started seeing fantastic things like the Lightning Fighter and some of the more exotic products that they came up with. And it was also a fascinating time too, because just suddenly you started to see the motor industry change, principally with the introduction of the E-Type Jaguar. And everybody saw that, the first 150-mile-an-hour car. Whether it did 150 or not, I don't know, but it was astonishing. And suddenly you thought, wow, this country's really going somewhere, I really want to be a part of this. How am I going to do that? Innovation's a very big subject. It really is, and it's a very big cultural subject. If you're going to go out and break records, then you've got to innovate. You simply, if you produce something which is similar to everybody else's, you might just get a record, but it'll be a marginal one at best. What you've got to do is go out there and really achieve something spectacular. And so therefore, you have to innovate and you have to take substantial risk in terms of design and build and operation and all the rest of it. And so your organization has to have a culture which is about a risk-taking culture. And you've got to make sure that everybody understands that, yeah, we're going to take risk. We're going to try this, we're going to try that. If that's going to give us a few more miles an hour, we should adopt it. The problem, of course, is when you meet the interface with the rest of the world. And so what we've got is an extraordinary country here where we don't take any risk at all. So here you have us taking risk and talking in terms of building a supersonic car and actually building it and delivering against a culture which just doesn't understand it and really doesn't want to take part. And one of the most difficult things about all this is the sponsorship side of it. There are two elements of this. One is you're going out there and you're going to meet boards and give them presentations on what you're trying to do. And you, when you talk to them and you explain how they can make use of their involvement in the project and how it really works, you quickly realize that none of these people are actually going to make a decision. You're there for the entertainment, but it's unlikely that any of them will make a decision. I've done hundreds of these meetings. And of course, the fundamental problem is that in these large companies, people don't take risk. They join the company at the bottom level and they work their way up. Basically, they don't take risk. They do what they're told. They work in a hierarchical organization where you are told what you're going to do, and that's it. And so when it comes to actually being faced with a decision about taking risk, they won't. They don't know how to. Whereas we're different because basically we're taking risk every day, and we know, and over 40 years of doing this, you know very quickly what you can do and what you can't do. And you've got to be able to make those decisions really quickly. Right, let's have a go. That one might just work. That one, no, for God's sake, don't do that. Don't try that. And so you push on hard with innovation. So if you think of thrust SSC, twin afterburning spay engines, basically rear wheel steer, active ride, the first ever use of computational fluid dynamics on a car, rocket testing, everything about that was innovation, and a determination by the entire team to get there at the end. Then the other side of it, which is really extraordinary too, is the sponsor side. So you build up this tremendous relationship with the sponsors because these people are brave. They're working in a large corporate organization where people don't really normally stick their necks out. And though they are, they're doing that, and it's going well. And as long as you're delivering in terms of providing high levels of publicity for them, this is great, works very, really well, they're very pleased. However, there comes a problem. The problem is when you decide to go abroad and run the car, and that's when they run away. It is extraordinary. They'll support the build of the car, the development, and all the rest, but when it comes to running, they run away. I don't think it's possible to teach it. I really don't. I mean, you can obviously explain it and you can give examples of innovation and how it works. But the fundamental problem really is that you have to have the innovation culture. You have to really want to do it. Determination to do it, to show people that it can be done. And of course, each time you innovate and create something new, then the whole world moves on because they learn from it. And this is where we learned that these projects are incredibly valuable for education. And we had a bit of a disaster with the Bloodhound project because the government let us down, which was a disgrace, but there you go. But our education system was engaging with 127,000 kids a year. That's simply enormous, very powerful. And you saw fascinating examples of this. 11 and 12-year-olds talking about Mach numbers. Amazing, absolutely amazing. And there was one particular effort where a teacher who had set up a program for after schools education, and he decided he would focus on Bloodhound. And he sent me a mail one day and he said, look, we're getting on really well with this and I'd like the kids to meet Andy and you. And can we fix that? And I said, yeah, of course we can. And Andy and I fixed it and we had a meeting with them. And these kids were asking us questions we couldn't answer. And that was just so stimulating. It really was. It really was showing that it really does work. And the fundamental problem is that the education system here in this country now is run on rote. So the whole idea is to get the kids through the exams. The quickest way of getting through the exams is learning by rote. And I've been at schools where you see notices on the notice board saying, always remember the answer to this particular question is that, remember that. In other words, they'd never be able to derive how they got there, but they knew the answer. Well, I'm very biased, of course, but the simple thing is you've got to get rid of the hierarchy. The hierarchy is the killer because you end up with these huge organizations and the people at the top are steering them have very little contact with the people at the bottom. And so, as you know, what happens at the top, they make crass decisions. Everybody gets really pissed off because basically they're not in touch and they're not actually working as a team. You've got to get them working as a team. You've got to change the entire culture. So I was very privileged. I taught management for an American company many, many years ago. And I was able to discover the learnings and the teachings of Abraham Maslow, going back to 1941. And he then basically explained how this really should work and how people have to integrate and communicate with each other. You hear so often the problem of people working in silos and not communicating with each other. And there's chaos when everything comes together and the things don't fit. And we had that at one stage with the thrust SSC program where two engineers wouldn't talk to each other. Bits started to appear on the car which conflicted with each other. The guys building it were saying, "Are you sure you've got to put that there? Sure. Isn't there a shaft going in that direction?" we got that sorted out very quickly. But I mean, that's typical of the whole thing.
Can you tell me about that?
Yeah, this was an extraordinary story. From time to time with these projects, you get stuck over something, particularly if you're innovating and you don't know how to solve the problem and you don't have the money to solve the problem. Of course, if you've got the money, then you just spend the money, don't you? But we never have the money, so we have to think. And so in the cockpit of thrust SSC is a Mach meter. And the Mach meter basically gives Andy, the driver, the Mach number of the car. So it's got a needle on it and it shows the Mach number. Mach 1, of course, is supersonic. And this instrument has two pipes that go out the back of it. And one goes to the boom on the front of the car, which is effectively measuring the oncoming air. And it's got to have a reference pressure. And normally on the side of an aeroplane is a thing called a static port, which is very carefully positioned, which provides the reference pressure. So the instrument measures one against the other and then gives you a reading. So fairly straightforward. But the problem is the reference pressure. And the problem is, where are you going to put the static port? So we were stuck over this. We got the instrument in our hands, but how the hell are we going to make this thing work? And it was Farnborough Air Show time. So I went down there and I went round and I found the Americans who were really excited by this. Hey, this would be really different. We'd love to do this. So we all got talking and they said, yeah, we'll do it for you. Good, excellent. What's the deal? Well, you've got to pay, Richard, they said. Yeah, okay, right. What are we going to have to pay? Well, it'll take 3 months. We'll have all your CFD work, and basically we can do it for you, and it'll cost $130,000. And that's a discounted price. That's very special. I said, well, thank you very much, but we haven't got $130,000. So have you got any other ideas? And they said, no, they hadn't. So that was the end of that. So I then went back to the engineers and said, guys, I'm terribly sorry, I've failed. So we're going to have to come up with something else. And it was actually Andy Green who came up with it. And basically, what the solution was very simple, was to use a vacuum flask in the cockpit with a tap. And so the idea was that before you run the car, you open the tap, you trap the local air pressure in the vacuum flask. You then switch off the tap, you've got it locked, and that's your reference. And it costs us $50. Always on time, always on time. You've got to get across to the people you're meeting that everything is crucial, everything is planned, everything is absolutely time dependent. So timing is very important. You've got to be at least 5 minutes early. Well, I love this watch. I mean, it really is very special. Andy and I have seen an awful lot of watches, really one way or another, but this is absolutely brilliant. It's so clear. Of course, you know, Andy's a pilot with 3,000 hours. I got about 1,000 hours. And the interesting thing is that, you know, when you're flying, you want a nice analog instrument. You just look at it like that for a second and you've got the time, or you've got the reading and everything else. And that's what you've got with the watch. It's brilliant. And a nice stopwatch as well. But it's nice. It looks great. It looks very special. And I don't think I've ever seen a watch like it before. So that's very, very special.
How has it come together?
Well, Brooklands is an extraordinary story. I mean, it really is. And it was a combination of flying and motor racing. The problem was that when it was first opened, the motor racing was, because it's quite a big track, was boring. People weren't really very excited by it. But they were excited about the flying. So they would come in huge numbers to see the flying. So the motor racing guys had a bit of a problem here because they've got to hold their end up. And so they started to allow these big, huge racing cars like the Railton, the Railton, yeah. And so suddenly this became very exciting indeed. And you saw really, absolutely flat-out racing. An extraordinary sort of relationship between what was going on. So at Brooklands, let's leave the airplane people to one side, but at Brooklands, basically, you've got the engineers, people like Railton and so on, who were working, basically looking after the cars, developing the cars, building the cars. And then you've got the drivers. And the drivers generally lived up the hill in Kingston Hill. And they came down to play occasionally. So that's what actually happened. They would then drive their cars absolutely at the limit. And so, you know, you've got some really spectacular experiences for the people. And so the thing built up and up and up. Of course, when World War II came along, that was sadly the end of Brooklands in terms of a racetrack. But of course, in terms of its history and its development. And of course, also in the 1930s, we just look back at that. As these cars got bigger and bigger, the world land speed record became more and more important. And of course, they couldn't actually, there were only 2 land speed records which were actually taken at Brooklands. So consequently, those people started building bigger and bigger cars. And of course, after World War I, all these old aero engines were available. And the 444 was very special because, of course, it came just at the end of the war. First ran in 1917, into production 1918. And it stayed in production for the better part of 15 years. It was an astonishing story. And really, it held Napier together for a long, long time. Very clever engine, very clever indeed. And of course, in due course, it was supercharged and taken up to 1,500 brake horsepower, which was quite something in those days. Well, I hope so. You see, the important thing about these record attempts is really that in the past they've been used as vanity projects. In other words, making somebody famous and giving them an opportunity to generate large revenues and so on and so forth. Whereas actually we discovered with the Bloodhound project that the key deliverable of these is the education. We found the kids were getting hugely excited. We had a famous day in Cornwall where we ran the car there. We had 300 kids there. You've never seen the look on their face. Andy sort of set off down the track and by an afterburn, you know. It was great. You suddenly realized this is powerful. This is worth pushing for. Okay, thrust to run. Right, well, this is how it goes. You're on the track and you're at one end of the track. The track is 13 miles long. And in the middle of the track is the measured mile. And you've got to get across that measured mile as fast as you possibly can, as fast as the car will enable you to go. The thing about it is that, first of all, you've got to be very, very careful about the start of it and making sure that there isn't anybody on the track. Because the horizon is only 2.5 miles away. Okay, and you could get stray Americans on the track if you're not careful. So you've got to have an aeroplane. So the aeroplane flies up and down and checks the track to make sure that there's nobody on it. Then the next thing is that you get the start up. So we have a little gas turbine which provides the starter air for the engine, and it gradually winds up. And you sit there in the cockpit, and then when it reaches a certain percentage, you just advance the throttle very, very slightly. That opens the HP cock, so suddenly fuel flies in, starts going in, and then you've got combustion, and you hear a sort of rumble as the engine starts to come together. Then you've got to run through all your checks, make sure that the jet pipe temperature is okay, and if we've got oil pressure and everything's working all right. In the meantime, the rest of the team are removing the little gas turbine starter. So there you are, you're on your own, and you're waiting for the signal to go. And you hold the car on the brakes. So the brakes are always left foot braked, not right foot, left foot brakes. Right foot is accelerator. And the accelerator is very interesting because it's designed for two-way movement. So you can press down and you can pull back to shut the engine off. Okay, so you can control it all with the right foot. So the next thing is to, as soon as you've got the message to start, okay, you hold it on the brakes and you accelerate the engine very gently to 92% of maximum RPM. And you check the jet pipe temperature that, check everything's all right. And that's probably the last time you really look at the instruments. The problem is that everything happens so fast, you've got to concentrate on everything ahead. You're looking 2.5 miles ahead. You haven't got time to refocus to look at the instruments. So you sit there, you're on the brakes, and you know that you're always fuel critical. One of the problems with these cars is it's very easy to get the fuel consumption and the fuel capacity wrong. So in our case with Thrust 2, we were very sensitive in terms of the amount of fuel we could carry. So then you hold it on the brakes. Right, the moment comes to go, you hold it on the brakes, take it up to 92%, and then brakes off and slam accelerate to full throttle immediately. Okay, and that brings in the afterburner and it lights up within 30 feet. So there's an enormous bang and the car's gone. And you're accelerating around 2G. So in other words, that's what we're doing. We're doing over 40 miles an hour per second. And you're accelerating steadily, and it's like traveling in a fast jet. There's just absolutely, the engine never runs out of breath. You don't have to change gear or anything like that. There's just a relentless push in the back. And you've got a lot of problems. The problems are basically that you must never ever lift up your throttle foot, because if you do, it affects your top speed, even if you lift up for a second. So it's got to be always absolutely flat on the floor. You're controlling your speed by the distance that you're running in. So between 0 and 300 miles an hour, it's fairly unpleasant because the car is unstable. You haven't got tires on this car, you've got solid aluminium wheels running on an alkali playa desert. Okay, and they don't grip very well, they don't grip as well as a tire would. So the car is sliding all the time, and you're doing a bit of this and that to keep it all straight and keep it within the line. And you've got a lane which is 50 foot wide, and you've got to stay in that lane. There are lots of parallel lanes because, of course, you damage the surface behind it. But you mustn't leave your lane. If you leave your lane, you're going to screw it up for the others. So basically, you've got to stay in that lane. And then eventually you get to about 300 miles an hour, and the car starts to settle down. And from 300 miles an hour to 550 is, it's interesting, it's slightly boring, just going faster and faster and faster. 550, the engine starts to roar like an enormous organ pipe, which is stimulating, particularly because you're sitting next door to the turbine, which is just by your left shoulder. And then around about 500, just 570 or so, the first shockwave appears, and that shockwave appears on the top of the intake. So you can see a white whisper there, and it goes right the way back through between the two fins at the back. And that's where the airflow is locally going supersonic. And then at 615, you see the shockwave established over the wheel arches. That's when it's going, the airflow there is going supersonic. It's going supersonic underneath you, so God knows what's going on underneath there. And and then you're coming up to the start of the measured mile. Now the extraordinary thing about this is I've been doing this on a daily basis. Literally every day, whenever the car's serviceable, you go out and you add a few more miles an hour, you learn a bit more about it, you learn a bit more about yourself. And so what happens is your mental processes speed right up. So everything happens in slow motion. And you can see at 650 odd miles an hour, you can see every single detail on the track come up and underneath the car, even though it's going this phenomenal speed. But your brain is working at a phenomenal speed, so therefore, in relativity terms, it's actually slowing. It's actually very slow. So if you talk to a top Formula One driver, they'll tell you that the secret is getting the brain part to really work fast, so it all happens in slow motion. So you're through the measured mile and you're at your peak speed, and the peak speed we ever achieved was 650.88 miles an hour. You're through the measured mile, and now I've got to think about stopping. So this is a dangerous, very dangerous situation, because you're going faster than the car's ever gone before, and you don't know quite what's going to happen. So you come back on the throttle very, very gently, and as you do that, that cancels the afterburner. Then there's a big problem, because the engine is slowing itself, and because it's slowing, the air is building up at the intake. So you've got a great column of air trying to get through the engine, this huge speed. And there is a real danger that it will cause the car, destabilize the car, and it'll go sideways. If it goes sideways, then the air goes over the car, you've got to transfer this airflow over the car, and it'll fly, it'll go straight up in the air. So you've got to hope it's going to stay straight. And those two tail fins help enormously. You've got to count to 3, so it's 1, 2, 3, and only then can you start to shut the engine down, because you've got to let the engine cool itself. So you come back on the throttle, so you pull back on the throttle like that. That shuts the HP cock. The engine then has got no more fuel. And at the same time, you touch the button. You literally just touch the button on the steering wheel. And as soon as you touch that button, basically it fires the parachute. So at the back, we've got an explosive charge, fires out the brake parachute, which is a supersonic brake parachute designed for the UK's nuclear bombs, designed to take 700 miles an hour at least. That comes out with a bang, bang like that. You're on 200 feet of cable, which is nylon, because with nylon you get the extensibility, you get 20% extent, and you get a deceleration which can be between 5.5 and 6G. And you get an extraordinary effect called the cinematographic illusion. So so basically your balance is given to you by your ears, and under these circumstances the ears can't cope. And so you've got this violent deceleration, and the picture changes. It affects your brain and the picture changes. And it's as if you're driving straight down into the middle of the world. Extraordinary experience. Only for a few seconds, and you're down to 400 miles an hour or so, and then you're back to sort of gentle running then at that point. And that's the speed really where it all becomes incredibly boring, and it's all over anyhow, so you almost feel that you want to open the door and get out. You're down to 400, then gradually down to 200. 200, the parachute isn't doing very much, it's just dragging along on the desert. And then you can start to bring the wheel brakes in. And you bring it in, and you bring it to a halt, shut everything down, write down all the instrumentation. And within 2 or 3 minutes, our Jaguar is alongside with the crew there to get all the information and data and everything else. That's it. Oh, I loved it. I mean, I absolutely loved it. I loved driving the car. Given the chance, I'd get back in it and drive it 600 miles an hour tomorrow, but of course it wouldn't be ready. But yeah, I absolutely love it. And but the problem with the whole thing is that it's a huge, huge effort by everybody, and the record is the team's effort. That's the point. It's not one man's effort. It's a team's effort. And suddenly, at the end of it, you suddenly realize it's all over. There's nothing to hold the organization together again. It becomes incredibly sad, actually. It's all over. There isn't a future.